Hello everyone, welcome back to my channel Engineering Research Center. I'm Ritam Pramanik and today I'm going to make a rectifier circuit. First I'll make a half wave rectifier, then I'll make a bridge rectifier, and we know that for making half wave rectifier we need a single diode, and for making a bridge rectifier we need a 4 diodes. And also I will see the waveform of input side as well as the waveform of output side. And you can see here this is a diode, and we know that the diode only can work in forward bias. Diode cannot work in reverse bias. That's why we get only one half cycle in the output side. And wait for making this circuit, and we can see the output in the oscilloscope. And this is a anode side, this is a cathode side, and I connect positive side to anode, and this is cathode, and we are getting output from this side, and this is a output oscilloscope. This one is output oscilloscope for seeing the waveform of output side, and this one is input side, input oscilloscope. See, now I am going to simulate this circuit. You can see here this is input is 50 Hz. Our supply voltage is also 50 Hz in India, and this is I applied 5 volt 50 Hz supply. This is a 50 Hz, this is a positive half cycle, and this one is negative half cycle. In the case of output of a rectifier, this is a half wave rectifier, we are getting only positive half cycle, and we know that diode only work and for before making this circuit I told you that diode only work in forward bias, diode cannot work in reverse bias. That's why we are getting only a positive half cycle. We are getting only a positive half cycle, we are not getting a negative half cycle because diode cannot work reverse bias. When the positive pulse is going through the diode, that time it's conducting. When the negative pulse is going through the diode, that time is not conducting. That's why you are getting this type of waveform. And now I am going to make a bridge rectifier. You can see here this is 4 diode, and I will connect this cathode. This is a cathode, this is an anode, and I will connect this cathode to another diode anode, and I will connect this anode to this anode, and this is a cathode side, and this is also cathode side. I will connect. This is our, and you can see here the diode connection. This is a diode connection, and now we are getting the supply, and I will connect the supply side is a positive cycle, positive cycle supply, and I will connect here positive, and I have to connect also the negative side. This is our input side. You can see here this is our input side. This one is for positive side and this one is for negative side. Now I am going to connect with oscilloscope. Connect the input side oscilloscope with the supply terminal, and I will connect the second oscilloscope with the output side of a bridge rectifier. This is our input side, input oscilloscope, this is output, and we'll get the output from this side. You can see here our connection has completed. Now I am going to simulate this circuit, and you can see the input is 50 Hz 5 volt, and the output is also we are not getting a negative half cycle, only we are getting a positive half cycle. And you can see carefully the amplitude side, the input side amplitude is high than the output side amplitude. When the amplitude is decreasing, and when the amplitude is decrease more and more, that time the output waveform look like a DC. This bridge rectifier can convert DC but not purely DC like battery. We are getting the output from the battery is purely DC, direct current, and in the case of bridge rectifier we don't get the direct current. Direct current means purely DC. We get DC but not purely DC. And I hope you understood what is rectifier, what is bridge rectifier, and also half wave rectifier. You see the waveform of input side and also output side. And thank you for watching this circuit, and if the video is helpful for you, then you may subscribe this channel. Thank you.